Welcome to Lab 31, how to implement dependency injection with MVC. Now, before we move ahead and we show how to implement dependency injection with MVC, first let us try to understand what exactly is dependency injection. Now, in order to understand dependency injection, you need to first understand inversion of control. So basically, inversion of control and dependency injection, they are very much connected with each other. So what my suggestion is to go to the design pattern section. So log into your Questpon video site, go to the design pattern section and watch these two videos first. So you can see here we have two videos here. One is inversion of control, that is IOC, and the second video is dependency injection. So first go and watch these two videos and then continue with this video ahead. Now, in order to understand dependency injection, what I've done is I have added one more field to our customer project called as customer discount field. This customer discount field is calculated by various ways. So for example, the first way is by seeing the customer amount. So if the customer amount is above certain amount, you get a X amount of discount. The second way this discount is calculated is by looking at the sales date. So if the sales date is, let us say, Saturday or Sunday, then you get some X amount of discount. And the third way of calculation is by looking at the age. So if he is a senior citizen or some kind of a old person, then you get a X amount of discount. So what I've done is I have added a customer discount field here, and the customer discount field is calculated by various means, by using a customer amount, by using sales date, and by using the age. And also I have added one more field here called as the customer type. So you can see here, if the discount is calculated by using the customer amount, the value here is C. If the discount is calculated by looking at the age, then the value here is A. If the discount is calculated by looking at the date, then the value is D. So later on, if we ever want to know that how this discount was given, then you can go and look at this field here, and from this field you can understand how the discount was calculated. So there are four fields which I have added: customer discount, customer type, sales date, and customer age. So let us see now in our customer project how our class will be structured as per this new requirement. So as per the new requirement, in the customer class, what I've done is I have added four new fields. You can see, or four new properties, I'll say rather: customer discount, sales date, age, and customer type. Right. So as per the new table design, I have added these four properties to my customer class. So now what would happen? The end user will come, the data entry user will come to your site, and he will say, okay, he wants to enter a customer. Now he will specify, by clicking on a hyperlink or must be checkbox or whatever, right? He will give some kind of a signal from the UI saying that yes, he wants to enter a discounted customer by age, he wants to enter a discounted customer by sales date, or he wants to enter a discounted customer by the customer amount. So depending on what kind of data entry mode he is in, right? When the customer amount is set, so when the set of the customer amount happens, you'd like to go and calculate discount at this place. So at the set, you would like to go and calculate the discount accordingly, right? So technically speaking, we will have a if condition here. So this if condition will decide first, what the user action has been initiated. So if the end user has initiated action where he says calculate discount by age, then you will have a if condition here like this, and you will have the calculation of discount logic here. So calculation of discount by age. In the same way, for different other actions, where he says that, okay, calculate the discount by using the customer amount, calculate the discount by using a sales date. So in the same way, you will have more if conditions here, right? So technically speaking, when the customer amount is set, you will actually decide the calculation by using if conditions like this. But now this approach has a problem. The problem is that it is violating solid principles. It is violating the O of the solid principles, that is open close principle. The open close principle says that when new changes come into the system, rather than going and modifying the existing code, try to add those modification in an extended way. In other words, for example, tomorrow somebody says that, okay, can you calculate the customer discount by using the gender, let us say. Okay, so that means you will go here and add one more if condition. That means you will change the existing code. So rather than doing that, how about going and using extension? So the O of that solid principle says that rather than modification, use extension. And in case you want to see a more detailed example, what I would suggest is go to the design pattern section and watch the video of solid. So I have explained all the 4 or 5 principles of solid, that is single responsibility principle, open close principle, list scope principle, so go and watch that video so that you will get a better idea of OCP. So that means this is not a good idea. So rather than going and putting if condition here again and again, how about I do like this? How about I say that, okay, so I have my customer class here. How about going and saying, okay, let me extend this customer class. Okay, so I'll say, okay, let's extend this customer class, let's inherit this customer class, and let's create a new customer class here saying discount by age. Okay, must be I can say cust discount by age. Okay, so this cust discount by age will inherit from the customer class, will inherit from the customer class and will add logic of calculating the discount by age. In the same way, I would again go and create new classes which will inherit the customer class and do the custom discount calculation. Now, in order that the child classes, that is cust discount by age, cust discount by customer amount, cust discount by your sales state, right? These child classes, would need placeholders or would need plugin points where they can go and plug in their custom code or where they can go and plug in their custom logic, right? So in other words, the customer class, that is the parent class, should define plugin points. That means now at this moment, if you see, when the customer amount changes, we go and calculate the discount, right? So I would like to have a plugin point here, where the child classes can go and override this logic, right? So for that, in our parent class, we need to go and define this property as virtual so that the child classes can go and override this virtual. So they can go and override this customer amount and they can go and plug in their custom logic of discount calculation, right? So over here, because this class is at this moment calculate discount by age, what I'll say here is, okay, if this dot age is greater than 50, that means if he is a senior citizen, I would like to go and set the discount as, let us say, 10%. Okay, so I'll say here this dot discount, right? Now remember that this discount as well as the type of the customer, I have made only a get here, because when somebody goes and creates the object of this customer class, or when they use this customer logic, right, I don't want them to decide what is a customer type or what is the discount. It should be internally calculated, right? So that's why I have made it as a get. But now, because the child classes needs to access this customer type and the customer discount, what I'll do is, rather than making this as private, I will make it protected. So by making this thing as protected, what I can do here is, now I can access those variables. So I can say this dot customer discount is of 10% and this customer type is calculated by using the age discount, right? Right. So in this way, whenever you have new demand coming in saying that, okay, now can we go and add a logic, which will calculate discount by using this? Then you just need to create a class, inherit the customer class, go and put your custom logic in the customer amount set, and you are done. So basically, rather than modifying the existing code, we are now inheriting and adding things. And this is more plug and play model as compared to the previous one, where we were thinking of putting a if condition right on the single class, right? Now also I have added two more classes here. One is discount calculation by amount, and the other calculates the discount by date. So you can see here that I have added two more classes, and both of these classes are again added in a plug and play manner. In other words, they actually inherit from the customer class, and the logic is then written here by overriding the customer amount property. So you can see here in the customer amount calculation, I am saying if the customer amount is greater than 1000, then the discount is 15, and the customer type is C. C stands for customer discount calculation by customer amount. Okay. In the same way, the other class here, which is customer discount calculation by date, says that if it is Sunday, then there is 20% discount, and I'm saying here D customer type, which says that this calculation is happening as per the date. Okay. So you can see here we have ended up with a kind of a parent-child relationship, where there is a base class called as customer class, and the customer base class gives you opportunity to override the customer amount logic, and all the child classes define the discount calculation by overriding the customer amount property. Okay, so that's our class structure, and I think we have done here. Now the next step is to go and consume this logic inside the controller. So we would now go ahead and see that how we can consume this logic inside the controller in a proper manner. Now the way most of the developers would consume this customer class inside the controller is something as follows. So they will go ahead and they will create the object of the customer class like this, right? And depending on scenarios, depending on how the request comes in, in the constructor or somewhere, they will decide saying, okay, if the request has come to create a discounted customer using a date, so they will say here, okay, obj customer is equal to new cast with discount by date, right? Or else, they will say, okay, else go and point towards new cast discount by age, right? So basically, if you see, most of the times, developer would use this methodology. So they will go and create the object somewhere in the customer controller, and depending on situations, they will go and create the object of discount by date, discount by age, or discount by amount. Now, if we consume the customer class this way inside the controller, then tomorrow when we add a new logic of calculating discount, we have to again go and write one more if condition here. So in other words, at one side we have created this beautiful class structure, and we want to have a decoupled system, right? And then at the other way, the way we are consuming that class structure is completely not following best practices, right? So we would like to follow best practice. We would like to ensure that when new type of discount calculation is added, we don't have to go and change the controller. In other words, we would like to create a decoupled system. We would like to decouple the controller class from the customer classes or from the customer logic. So for that, we need dependency injection, right? In other words, rather than the controller class deciding that which customer object has to be created, how about going the other way around? How about saying that, okay, I am the controller class, right? But my work is not of deciding which customer class has to be created. My work is to take the post request, take the get request, execute it, execute the same. But if I get into deciding that which customer class has to be created, then I'm overloaded with things, right? So how about something like this? So how about if the customer controller class says that, okay, pass me the customer object, right? So anyone who is going to use me, let him decide what kind of customer class he wants to inject here. So you can see now what I've done is I have created a constructor of the customer controller class, and over here I am passing this abstract class here. So this abstract class says here, this constructor says here, okay, pass me the customer class, but let me not decide, I will not decide which customer discounted class object has to be created. So in this way, now if you see, the customer controller is now decoupled from the customer logic. So tomorrow we keep on adding new customer logic, and the client, whoever is consuming this customer control class, he has to decide and inject which object has to be injected here. So the customer controller class has no idea that you have discount calculation by code, discount calculation by amount, discount calculation by age, whatever. But now let us go one step ahead. Activities like object creation, why should even they be part of clients who are consuming the controller class? Right? Because if you look at activities like object creation, they should be part of some project, which is called as factories. Normally, if you look at factory pattern, in case you are not aware of factory pattern, you can go and see the design pattern section where we have factory pattern explained. So object creation activity should be a part of some third party framework. If you want to really make this implementation very clean, it should be a part of some third party framework. It should not be a part of any code of a project. Because if you see, initially the object creation part was of the customer class. So we said no, this object creation is not the work of customer class. We removed that and we moved into the controller. Afterwards we said, oh, the object creation is not even the part of controller. So we want to now remove that and move it to somewhere else. So let us go one step beyond. Let us make it very clean. Let us say that this object creation part, is it possible if we can delegate it to some third party framework? And that's where exactly dependency injection comes into picture. Dependency injection, what it does is, it actually takes the help of some third party framework like Unity application block or MEF, right? And these third party frameworks, they are aware, what kind of objects have to be injected for whom. So in that third party framework, at this moment, we will use Unity application block. We will go and say that, okay, inside the customer controller class, please go and inject, must be cost discount by age or must be cost discount by amount, right? So let us go and first reference Unity application block, and then we will define this injection mapping. So let us go to our solution explorer and let us reference Unity application block in our project. So let us go and open the NuGet package manager. So let me right click on this project here on the web API project. Remember, whatever changes we are making currently, we are making in the web API project, because the web API project has those customer classes, right? So I'm going to go and say manage NuGet packages, and in this we'll search for Unity application blocks. Again, I repeat, please do go and see the videos of dependency injection, where we have explained how to use Unity application block to do dependency injection and inversion of control. What happened? Okay, so there the search has come up. Now you can see here, this one, the first one which you see, the Unity application block, right? This Unity. This one is that base component of Unity application block. So in that design pattern section, I have explained this core framework of Unity application block. But now you can see that there is just down below, there is one more thing called as Unity Bootstrapper for ASP.NET MVC. So rather than using the core framework, we will use this, because in this, you get some ready-made shell code so that you don't have to go and write up the bootstrap logic. Okay. So rather than using the core framework and doing again everything from scratch, we will use this. And in case you want to understand how the core framework works, please go and see the design pattern videos for that. But at this moment, I will go here and I will install this. Now, one of the things which will come to your mind is, what is the benefit of referencing Unity with MVC? Rather than just Unity, what is this Unity with MVC NuGet package? What extra thing it actually gives us? MVC with Unity gives you a couple of classes. And one of the class, which is very important, which it actually gives you ready-made, is this dependency resolver class. This dependency resolver class helps you to decouple your DI framework from MVC application. If you remember, I said that dependency injection can be implemented in multiple ways. It can be implemented by Unity application block. It can be implemented by using ninject. It can be implemented by using MEF. So tomorrow, if you think that yes, I want to go and change my dependency injection framework, then you don't have to go and change all over the place, right? So this dependency resolver class, you can think about it is like a layer which sits between your MVC application and your dependency injection frameworks and decouples them, so that tomorrow when you go and change your dependency injection framework, you don't have to change all over the place. But I would like to clarify a point here regarding this dependency resolver class. This dependency resolver class is meant only if your controller class is inheriting from that controller class of MVC. In other words, if your project is pure MVC, then it is fine. But if your project is web API, where our controller class actually inherits from API controller, then this dependency resolver is not useful at all. So in other words, at this moment, whatever dependency resolver we have received right in this project is not useful because our project is a web API project. So in other words, we have to now go and create this resolver class ourselves manually. So what we'll do is we'll take the same architecture, right, what they have shown here, but we have to create the resolver class ourselves because there is no ready-made NuGet package at this moment. Okay, so what I'll do is I'm going to go and delete both of these Unity MVC architect activator and unity.config.cs. I'm going to go and delete them, and let us go and create our own resolver class, okay, which can go and stand in between this API controller and our dependency injection frameworks. So let me go to the app_start folder and let me add a new class here. So I'm going to go and add a new item here. So I will go and add a new item, or I'll say rather this is a new class actually. Don't I see a class here? Okay, there is a class. So I'm going to go and add a new class here, and let us name this class as dependency resolver. So let me name this class as dependency resolver, or I'll say my custom dependency resolver, right? So I'm going to go and create my own class here of dependency resolver. Okay. So in this, what I'll do is I'll go and create my own class here. You can see I've cut pasted some code here, and I've named this as my Unity resolver. Okay. So this class, will actually help you to resolve Unity. Okay. In the same way, if tomorrow I have a new DI framework, if I want to use, I'll again go and create, let us say, my MEF resolver. Or tomorrow, if I am going to use ninject, then I will say here my ninject resolver. Now this my Unity resolver, I'm inheriting from I dependency resolver. So this is the interface I'm implementing. Let us go and resolve these dependencies here. I can see there are some dependencies here. So let us go and say, okay, use my Microsoft practices.unity. What else we have? Okay. So let's go and correct these errors here. I'll explain you what this code is. But let me correct whatever errors I'm getting here. Right. Okay. Let me just compile this project once, and then I will do the explanation part of it. All right. Okay. So everything compiles. That is good. So this Unity resolver class, or this my Unity resolver class, it is nothing but it is a wrapper around the Unity dependency injection framework. And the main purpose of this class is to decouple the MVC application from the DI framework. So you can see here, this Unity resolver does nothing, so depending on the service type, he just calls the Unity container to resolve and do the dependency injection. So you can see, rather than going through all part of the code, you can see at least this get service method here, he is just making a call to the Unity container. If you go again down below, there is a resolve method. He also makes a call to the container method, container or class. So in other words, the my Unity resolver, it is nothing but it is a wrapper around your dependency injection framework. And at this moment, it is a wrapper around the Unity application block. So now that we have the resolver, we have to inform our web API about this resolver. So whenever the web API wants to do dependency injection, or whenever there are objects to be injected, he just delegates the responsibility to my Unity resolver, right? So in order to go and inform your web API about the existence of my Unity resolver, what we need to do is we need to go to the web API config file over here, and over here we need to go and set the dependency resolver. So you can see here, this configuration has a dependency resolver here. So to this, we need to just go and say, okay, my Unity, what is that class? So my Unity resolver. So we need to just go and create the object of my Unity resolver and give to this dependency resolver. Now remember that this my Unity resolver actually needs the container, right? The Unity container. Okay, so we have to go and create the object of the Unity container. So I'll say container is equal to new Unity container, and we go and define the injection mapping here. So I'll say, okay, so if you find register type, so if you find customer, then how about going and injecting customer discount by date, right? Okay, if you find so I'll go and just define the mappings here. So must be we can just first start with injecting just cust discount by date. So you can see here what I'm saying here is I'm saying that, okay, register the type, go and inject the object of cust discount by date into the customer here. Okay, this is generic, right? And this container I'm going to go and pass to this resolver here. Okay, so I'll build here. Let us build this application. Let us hope that we don't have any errors. Right, so everything looks fine. That is nice. So what will now happen? If you see here in the web API configuration, I'm saying my resolver is a Unity resolver. Tomorrow, let us say that if you want to go and change this resolver to something like my ninject resolver, we have to just go and change this part of the code. So the basic purpose of this resolver class is to do decoupling. So I need to just go and change this one line of code over here, and then I can go and replace my complete dependency injection framework with some other different kind of framework, right? Okay, so we are almost done. So let us see what happens. So I'm going to go and just run this web API alone. So what I'm going to do is I'm going to go and put a debug point here, and I will just go and start this web API, and let us go and try to do a get call on the customer web API. Let us see what happens. So over here, I'm going to go and say API/customer. So let us try to do this. So there the request has been sent, and at the background you can see what is happening. So as soon as the request comes to the controller, the first thing the controller tries to instantiate himself, right? But the first thing what the web API framework does is he goes and he informs this dependency resolver saying that, can you please go ahead and scan my customer controller class and inject the necessary dependencies. So can you go and inject the dependencies, by the rules what we are provided to the container. So if you remember, in our Unity container, we had said that I would like to go and inject the cust discount by date object to the customer class, right? So you can see over here, when you go and move your mouse here, you can see the dependency injection framework via the dependency resolver has injected cust discount by date. So if you see this situation here, this is magic actually. This is magic, right? And this is what the goal of every developer is, to create a decoupled architecture, right? So you can see here, my customer controller class at this moment is pointing to the parent customer class, and the dependency injection framework is injecting the dependent objects from outside. So you can see now the complete object creation part has been moved to the Unity application block, right? So nice. So that means neither the customer class takes the responsibility of creating the objects, neither customer controller takes the responsibility of creating the objects. It is all done by the dependency injection framework. And also we have achieved decoupling here. So in other words, tomorrow if I want to go and add here saying cost discount by something, I will just go ahead and add the class here, and then I will go to the container and say that, okay, inject this object to this. Right? Nice. But we have couple of problems with this approach. So let us talk about those problems. If you see the current way of injecting dependencies, right, it is more hard coded. In other words, inside the customer class, always cost discount by date will be injected. But if you see our requirement, it is more situational. So in other words, depending on the way user will go and invoke this customer controller class. So at moments I would like to inject cost discount by date, or must be I would like to inject cost discount by amount, or must be I would like to inject cost discount by age. So I want more kind of a situational kind of injection and not hard coded. So in other words, my dependency injection container, that means my Unity, right, I would like to have conditional injection. So over here I would like to say, okay, so this is by date, okay, and I would like to also inject by amount, or I would like to also inject okay, so that's inject by age actually. So age, right, or I would like to inject by amount, right? So in other words, I would like to have more of a conditional injection and not hard coded one. So you can see here what I've done is I've said that, okay, I'm going to I have registered the injection by certain keywords here. So I've said that, okay, if you say D, then he will actually give you a cost discount by date object. If you say C, he will actually give you cost discount by amount object. If you actually say A, he will actually give you cost discount by age, right? So you can see now what I've done is I have done more of a conditional registration, and I would like that depending on scenarios, he should actually go and inject into the controller class, the object. Okay. So how do we go about implementing this now? Now for this kind of situational injection, dependency resolver is not useful, because if you see this dependency resolver, it actually runs on the startup. So definitely it is not useful for situational injection. If you look at the scenario of situational injection, the injection varies depending on request. So sometimes the request can come that he wants to calculate the discount by date. Sometimes the request can come he wants to calculate the discount by amount, and so on. So basically we have to inject the dependencies on every request, because every request can be of a different nature, right? So that's why this dependency resolver is not really useful. So let us go and comment this code, and let us see that how to resolve this. So if we try to analyze, what we really want is we need to have some kind of a factory class which will actually create the controller object, and this factory class will be hit in every request. So as soon as the request comes in, that request will be intercepted by this factory class, and this factory class then, depending on situation, will create the controller object. So you can see here what I've done is I've created a very simple class here called as custom controller factory, which actually implements HTTP controller activator. This interface is responsible to intercept every request that comes into the web API. So as soon as the request comes in, we will intercept this request, and depending on the request, we will actually go and create that controller object. Now this factory internally references our Unity application block framework. So you can see here we have a Unity object, and which has all the permutations and combinations of objects which can be injected in the customer class. So you can see here that we can inject cost discount by age, we can inject by date, we can inject by amount, and each one of these permutations and combinations I have lettered them. So you can see here A. So if you go and say to Unity, okay, give me give me A, so he will actually give you a object of cost discount by age injected into the customer, right? So if you say D, then he will give the respective injection. So you can see now I have this Unity application block which is referenced inside this factory, which has all the permutations and combinations of injections that can happen inside the customer object. Now this controller factory also has a create method here. You can see that there is a create method here, and this create method, if you watch very closely, this create method is fired in every request which comes to the controller. So before the request goes to the controller, it will first come and get intercepted in this create method. Now when the request comes to your web API, the request comes from a JavaScript framework, that is Angular, because all our screens, all our UI currently is using Angular. And Angular sends the request in which format? JSON format. Now the first step is that as soon as the request comes to this method here, this create method is invoked when any request comes in. So this create method intercepts that request, right? So the first step is to convert that JSON which is coming from the Angular UI into a C# customer object, right? Into a C# object. So for that, we're going to go and use the JavaScript serializer class here. And to use this JavaScript serializer class, we need to go and refer a namespace. So we need to refer system.web.extensions. In this namespace system.web.extension, this JavaScript serializer class is, and this JavaScript serializer class helps us to serialize and deserialize JSON object back and forth. Okay. So I'm going to go here to the frameworks, to the assemblies. So there you can see system.web.extension. So let us go and take this namespace and let us refer it. Okay. So in other words now, and here also let me go and resolve this error here, because now already I have the namespace. So I just need to go and put it in the using. So there it is. So that error is now gone. Okay, so you can see now what is happening is this JavaScript serializer class, right, actually goes and takes that request. So basically what it does is, first thing, if you see here, when the data comes in, it comes in the request object, right? So in the request object, I'm saying go and read the data from the request object by using this content, and then this string, whatever comes here, go and deserialize this object or deserialize this string into a customer object. So you can see the first step here is, over here I'm first extracting the data from the request object. Okay, once that data is in a, because now when the data comes in, it's in a JSON string, right? And this JSON string is converted here into C# customer object. Okay, and also I have created one more object here called as the cust injected object, which is of type customer. So basically this cust object here has the data, right, which comes from that Angular screen or which comes from the customer screen, and this second object, cust injected object, will be that object of the customer logic which will get injected into the controller. So basically you can see here how the rule I have defined. So basically what kind of object can get injected of the customer? That means, will the discount by age get injected? Will the discount by date get injected, or discount by amount get injected? That is decided in the following way. The first preference is the age. So if the age is greater than 60, then go and call the Unity application block and create the object of A. So use the A, the A letter, and query the Unity application block, and Unity application block will return cust discount by age. In the same way, if the age is not greater than 60, then the next preference is for the sales date. So if the sales date is equal to Sunday, then use the date logic. And finally, if these two do not meet the criteria, then try to use the customer amount. If it is greater than 1500, then use the customer amount logic. And in case if none of these criteria meet, then what we can do is we can just say, okay, cust injected object is nothing but it's a simple customer object, right? So you can see now, how dynamically, depending on situation, the customer logic will get injected inside the controller. Now, if you see the current situation, we have two kinds of objects. One is this cust object, which actually has the data which we have sent from HTML, because this cust object is filled by using the JSON data. And the second object what we have is cust injected, right? This cust injected has the type of customer, which will help you to calculate the discount. Okay. Now the problem here is that this cust injected object is fresh. In other words, when you say unity.resolve, he actually creates a fresh cust injected object and gives to you. It does not have this data. The data what has come from the UI, it does not have it. So basically we have to pass the data of this cust into the cust injected so that he can use that data and do the calculation, right? So in other words, we need to go and write logic something like this. Pass the age value to age, pass the customer amount to customer amount, right? Now at this moment we have just 4 to 5 properties. So when we have 4 to 5 properties, writing such kind of a code is okay. But what if you have properties which are 20 to 25 properties? It is difficult, right? So for that, what we will do is we will use something called as automapper. In case you are new to automapper, my suggestion is to go and see the .NET fundamental section where we have explained what exactly is automapper and what is the use of automapper. So what we'll do is, let me go to my NuGet package manager and let me refer automapper. So let me go to my NuGet package manager. So view solution explorer. So let me go to my customer web API, and so there you can see the automapper. So this automapper actually helps you to create mapping between two objects so that you don't have to write the mappings again and again. So I'm going to go and install this automapper inside my project. So now I can go and specify the mapping something like this. Now you can see here this automapper, it is actually a static class. So let us go and use the namespaces. So you can see in the controller factory, I'm going and creating the mapping, and I'm saying that, okay, when you map the discount age by customer, you go and set these values. So you can see here how I am actually saying that, okay, set this value to this, set this value to this. So basically automapper helps you to go and create the mappings, and later on, what you can do is you can if you say that, okay, now you can come back here and you can say, okay, mapper dot map, okay, and I can say, okay, map what, like, so I'll say, okay, map the cust discount by age, this object, okay, by using the cust type. So go and map the values, copy it and give it to cust injected. So once you have defined the mapping at the top here, right, once you have defined the mapping at one place, you can then go and use the mapping wherever you wish. So you can see here I'm saying, okay, mapper.map, map this this customer object, okay, copy it and map it to my cust discount by age. So this cust is actually a customer object, please note. And I'm saying transfer the values from here to my cust injected object, which is actually going to be dynamic. It's going to come from this Unity application block, right? So the automapper is nothing but it helps you to create a simple mapping between two objects so that you don't have to write the code again and again. So once you have transferred the values to your respective customer logic class, right, you need to go and take this cust injected object, this object which you wish to inject. You will go and create the customer controller object and pass this new injected object here, and then give this controller object back to your web API project for execution. So in simple words, if you see now the way the flow is, the end user will send a request, right? The request will first come to this controller factory. Controller factory has all the necessary things of saying which object can be injected. It also has the auto mapping, everything. So it will actually take this request, and depending on the request, he will go and create either customer calculation, customer discount calculation by age, customer discount calculation by date. So whatever customer type of object he wants to create, he will create that object and then go and create the controller class and pass the object, inject that object to that controller class. And what the controller class after this will do is execute the post logic or get logic. So in simple words, the first request will come to the factory. Factory will use the Unity application block and do the get the necessary type of customer what he wants, right? That customer calculation logic he will go and he will inject into the controller, and later on controller will go and execute is get and post method. So if you see now, this class, factory class, is the person responsible to do the injection. And whenever new types of customer are added, I need to go and just change this factory class, and I don't need to go and change anywhere in my project. My customer controller class, my web API class, right? It does not have to be aware of that what kind of customer he is going to get. He can get customer discount by age, he can get customer discount calculation by date, by amount, and tomorrow by something else. He does not have to know about it. So in other words, my controller now is completely decoupled from the customer class logic. So in short, now the post, get, put, delete should not be using this customer class from here. It should actually be using your injected object. Remember, the injected object is this obj customer. So this gets injected here, right? So he is going to use obj customer. And in the same way, we have to go and modify the put as well. Okay. So in other words, the first hit will go to the factory. Factory will inject, whatever type of customer object he wants to inject, and this controller class will actually go and take that customer logic object and go and do the insertion, updation, and deletion. Now with so many changes here, our data access layer also has to be changed. These changes are not small, right? These changes are huge actually. So this also goes and affects our data access layer a lot, because if you see now over here, this customers.add, this thing here, right? If you see, the currently our entity framework data access layer is saying that, okay, give me customer. But remember, this customer can be a type of a customer who calculates by age, who calculates discount by amount or whatever, right? So in other words, the data access layer needs to know that how he can convert this customer object or this customer class into the appropriate calculation logic class types, so that you can do the insert properly or the update properly, right? So we need to go and do lots of modification in this data access layer here. So let us go to the data access layer. So let us say go to definition here. If you see logically at this moment, the mapping is only between customer to the TBL customer. But now this customer class has lots of flavors, right? So what we need to do is we need to go and map even those classes to the TBL customer. So in other words, if you see now the scenario, we have one parent class customer, then we have other class which is customer discount by age, then we have customer discount by date, and then we have customer discount calculation by amount, and all of these classes are mapping to TBL customer. So here, if you look at the scenario, we have 4 classes mapping to the same table. So that's why our mapping now will become something like this. Complicated, right? So let me explain you this code. So in this code here, what we are specifying here is we are saying that the main parent class is the customer class, and this customer class is mapped to the TBL customer. But again, there are three variations of this customer class. Means in other words, there are three classes which actually inherit from the customer class. So customer discount by amount, discount by date, discount by age, and they also map to TBL customer. But these classes are differentiated, by using C, D, and A of the customer type property. So if you see in your database, right, your customer type has C, it has A, it has D, depending on which kind of customer class you have invoked, right? And in case it is not doing any kind of discount calculation, then I've kept the customer type as null. So this mapping here in your data access layer, ensures that basically whenever you go and say here in your code, when you say that, okay, go and add now the customer object to database, he will appropriately, depending on the type, will typecast that object to the appropriate type and do the insertion, do the updation, do the deletion, do the selection. So let us go and run this application. So let us do a Control F5 and you can see that there our application is running. Okay. The first thing you will notice here is, which I did not discuss from the code point of view, I have added two more fields here. One is the age and one is the sales date, right? Because depending on age, now the calculations can happen, and depending on the sales date, the calculation can happen. So in the view, I have added 2 or 3 more HTML over there, and I have not explained those HTML, but I'm sure that once you go and see the enter customer.cs HTML, you will understand this code. Okay. So now if you see here, now let us say, I'll say, okay, let us first do the age calculation. So I just give a name here, age cal. So I'll say AZX1001 1000. So if I put the age more than 60, and if I do a add here, I'm expecting calculation should happen as per age of 61. You can see the customer discount is 10%, right? Good. Now let me go and put something on the amount. So amount 123, I'll say, okay, AMT 6786. So if the amount is more than 2000, right? So if the amount is more than 2000 and age should be less than 60, so that the amount calculation of discount takes precedence, I'll say 2010, I'll say add, right? You can see now it is a 15% discount. And in the same way, you can go and check for the Sundays as well. So you can now see that we have a more flexible and a decoupled system. So the add customer is done, but the update customer and delete customer is not working. Why? Because we have done so many changes. We have added dependency injection. We have added multiple classes. So this update, to make this update customer and delete customer working, we have to do some code changes in the project. Now we have completed almost 15 hours of our training, and we have 1 hour more left out. And what I want now is, in this 1 hour, I want you to do things. In other words, in this 1 hour, I want you to take up this project and complete that update customer and delete customer. And believe me, it is not so easy actually. Especially that update customer, it looks easy, but it is not easy. Okay. So I will leave this project here, and the coming 1 hour, I would like you to go and download this code, go through it, set up your database, and try to complete the update customer and delete customer. And in case you have any problems, you can always mail to questpond@questpond.com. So that brings us to the end of Learn MVC in 16-hour series. So we have completed this 16-hour series almost with 31 labs, and every lab is in a range of 15 minutes to 1 hour. Okay. But rather than talking about numbers, rather than saying that I did 31 labs and I did 16 hours, but more than the number, the goal of QuestPond team, while we were creating this series, was the final result, and that is a project. That is a customer project. So if you see the customer project, that is our final output of this whole series. If you look at the customer project, it is using Angular on the UI side. It is using dependency injection to create your decoupled controllers. It is using entity framework as a medium to connect to SQL Server. It is doing single page applications. It is having web API. It is having validations. So basically our final goal was this project, because what my understanding is that if you complete anything with a project, so when you want to learn anything, if you do it with a project, you are almost done, because with a project you get a visualization of not only the fundamental but how to implement that fundamental in your project. So I hope that you enjoyed this series, and if you really like this series, right, and because this is the end of the series now, please go to facebook.com/questpond and put in your comments here, because it is very much possible that lots of people would like to see some more new addition to this series, right? We are officially ending this series, but we are still keeping it open unofficially for adding any new videos. But I will not promise right away at this moment anything, saying that, okay, I'm going to commit if you tell me that, okay, sir, please add this, and then I'm going to add straightforward. No, it is not like that. But yes, we will definitely give a consideration. And if you feel that it is important for this series, we'll definitely add lab 32, we'll add lab 33, and we can go on. Okay. So please go to facebook.com/questpond and tell us that how you liked about this series and what you want extra in this. Thank you so much.